Hello, I welcome you all. The problem reads a block A having a mass m is released from rest for the distance h and strikes the plate having a mass 2m. If the coefficient of restitution between A and B is E, determine the velocity of the plate just after collision. The spring has the stiffness K. So this one has mass m, this one has mass 2m. Right. So this one is falling freely. Okay, so it means there'll be need for us to find some velocity here. Okay, just before it strikes plate A. Okay, so then let's start. So say, mind you, we are dealing with impact. So say before impact, that is for before impact. So here we're just considering block before impact, just block A. Okay, only. So before impact, block A. So what do we do? So before impact for this particular block, it's falling freely, and conservative forces are at play. So conservation or energy itself is mechanical energy is conserved. So we can use the law of conservation of mechanical energy to compute the velocity before block A strikes B. So use the conservation of energy. All right. So what do we have? So say our T1 plus V1 is equal to T2 plus V2. Our T here is the kinetic energy, and our V is the potential energy. So here we know that since this is starting from rest, T1 is just going to be 0, okay, from rest, and then we have V1E is also equal to 0. Then we do have V2 both equal to 0. So what do we remain with? We only have W A H, and this is just going to be equal to half M A V A 2 squared. Okay, so rewriting this, we will have M A G H and equal to half M A V A squared. So we can get rid of this, and then we'll have our VA 2, which is going to be equal to square root of 2GH. So this is the velocity before impact. Okay, so now let's say after impact. So here we are considering block A and B. This is after impact. We are going to consider both of them. So considering a system of particles, momentum is going to be conserved. Therefore, we can use the conservation of momentum. So use the conservation of momentum. Okay, so we have MA VA1 plus MB VB1 is equal to MA VA2 plus MB VB2. And since this part here is 0, because our VB1 is 0 at this point, it is at rest, this one, and then our VA1 here is just equal to 2GH. This is what we found here. Okay, don't get confused with 1 and 2. Okay, so we're just using the same numbers, but we are in a state after impact. All right, so let me just create a boundary. So now we have, and we know that our MA is equal to M and our MB is equal to 2M. Therefore, this is, we have M square root of 2GH, okay, plus 0 is equal to M VA2 plus 2M VB2. And then this goes. Therefore, what we remain with is square root of 2GH. This is equal to VA2 plus 2 VB2. So this is equation 1. Then we've been given that E, okay, just equal to E, which is just equal to VB2 minus VA2 divided by VA1 minus VB1. Okay, considering that VB here is greater than VA2. And then we know the other values there, so we can write this as VB2 minus VA2. And then we know VA1, you said it is a 2GH, and then minus this part we said it is a 0. Therefore, writing this, you can write VB2 is just going to be equal to E square root of 2GH plus VA2. Okay, and this is our second equation. So solving the two equations, we are going to have square root. So solving the two equations, we'll have square root. This is going to be equal to VA2 plus 2 VAB, and this is just going to be equal to E square root of 2 like so. Okay, and then solving this, this we can resolve it. This and this adds up, which just becomes VA2, and then we are saying plus 2E like so. Okay, so working out this, our VA2 therefore is just going to be equal to this one the way it is, and then this and this subtracts, so we can factor out this. Okay, then we have a 1 minus 2E, then everything divided by 3. Okay, mind you, our reference is going down. This is our reference. Going down is our reference. Okay, this is our reference. Shouldn't forget. All right, so this is our V. So therefore, our VB2, we do have the equation. Where is it? This is the one here. Okay, so we do have this one and this one. So this is just equal to E square root of 2 like so plus um, um, this one like so 2GH divided by 3 minus 2GH 2E like so divided by 3. So if working out this, we have VB2 is just equal to square root of 2GH divided by 3, and then we have E plus 1. Right. I think this is about it. We have found the value of the velocity just after collision. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screencast.